Hello friends, welcome back. We are learning polymorphism OOPS concept. We understood what is polymorphism and we got some information like there are two types of polymorphism, static polymorphism which is also known as compile time polymorphism. Then another one is a dynamic polymorphism which is also known as runtime polymorphism. And there are two types, function overloading and operator overloading in static polymorphism, whereas dynamic polymorphism will be function overriding. Member hiding is also kind of a dynamic polymorphism. We know what is the difference between overloading, hiding and overriding. Overloading happens within the same class, whereas overriding or hiding happens in the derived class. Function overloading and operator overloading helps us to give new meanings to the functions or the operators within the same class, whereas member hiding helps us to hide the inherited members in the derived class. Same thing happens with the function overriding, like if we want to give new meaning in the derived class, then we can use the override keyword to override in the derived class. And when we were using member hiding, we have seen that our code might fall into redundancy. To solve the redundancy problem, we can take a help of virtual methods, and we have seen how the virtual and override keyword helps us to get the desired results, solve the redundancy problem. We took an example scenario of home appliances and we tried to simulate this scenario in the code. And of course, we have written a code to get the desired result. We created a graph, a diagram, a class diagram or inheritance diagram here you can see, and we understood in this diagram how virtual and override keyword works together, how the methods will get executed when we create a reference of a specific type. What we are going to do in this tutorial means we are going to learn about is keyword and as keyword, how they are helpful to solve some other problems that we might come across while writing the programs or sophisticated codes. So then let's get started. What I have here, you can see I have a class device which has a virtual method switch on. Its responsibility is to say device switched on. Then we have a TV class which inherits from the device class as TV is the device, and it overrides the virtual method switch on. And its responsibility is to say TV switched on. Then we have a AC class which inherits from the device as AC is a device, and it overrides the inherited switch on method, and its responsibility is to display AC switched on. Then I also have a refrigerator class which inherits from the device class as refrigerator is the device, and it also overrides the inherited virtual method switch on method, and its responsibility is to display refrigerator switched on. We also have a remote controller. At present I just comment that remote controller class, I save it. We have this much. Now what we are going to understand in this tutorial, as I told, we are going to learn about is and as keywords importance in code. Let's begin then. First I start with creating a TV. Let's take I create a TV. TV is equal to new TV. Here I created a TV class instance which is a derived class of device class, and we know that device class is a base class, right? I create a variable with the name device, and we also know that we can put the reference of a TV instance into the reference of the device class. Why? Because we know that base class reference variable can point to the derived class instance. So it happens implicitly. We won't get any error message. If I save and come back to Unity, we will not be having any error message. Only we have warning. The variable device is assigned but its value never used. No problem. Let's come back. Now here you can see that at present device is of type TV because it is pointing to the instance of a TV class. So implicitly it converts to the TV type. But as originally it is of device type, it can be able to access only device class members in the TV instance that we have seen. So here when I say device dot switch on, what happens we know already. I save this. we know that it goes to the device class first and it finds that there is a switch on method which is a virtual method. So it goes to its derived class, that is the TV class at present. It checks there is a method called as switch on which is overridden. So it executes that method and we get TV switched on the screen. If I save and come back to Unity, now we will not be having any error or a warning. If I run the code, we get TV switched on. You can see that we got TV switched on. We proceed further and get something more. Now as device is pointing to the TV, we very clearly know that at present device is of type TV. Originally it is of type device, that we should not fault. Now here what I do means I take MS Paint. Here we have a paint and I also take this graph. From this I am going to take device, I copy this, I paste it over here. We have a device class instance. We also have the TV class instance. I copy this, I paste it over here, and we know that TV is inheriting from the device class, and we know that this complete block is the TV instance. It is of type TV and it has the address #1 inside it, and we also have one variable with the name TV. It is of type TV and it has the address #1 inside it, and it is pointing to this instance which is created on the heap. And we have another variable which is a device variable, DEVICE, device. It is originally of type device, but as we have put #1 inside it, it is pointing to this derived class instance. Once it starts pointing to the derived class instance, implicitly it type converts to the TV type, but originally it is of device type, so it can be able to access only this part of the instance. And when we said device dot switch on, it has moved to this class and it finds their switch on method is a virtual method. So it moves to the derived class instance and it finds that there is a switch on method with the override keyword. It executes that block, so we got TV switched on the screen. No problem with this. Perfectly we understood. If you want, I can show also. If I say here debug.log, in a bracket I say device is of type TYPE, type, double quotation plus, I can say here device dot get type, bracket semicolon. If I save and run, you should see here device is of type TV because it is pointing to the TV. Implicitly it transforms to the TV type. If I save, come back to Unity and run and show you, first we get device is of type TV and next we get TV switched on. You can see that device is of type TV switched on. Now we proceed further and get something more. I can create a TV variable, let's take TV2, and I say here equal to device, semicolon. Now here you can see that right hand side is a base class variable, right? Because device is originally of type device class and device class is a base class. And the left hand side we have a derived class reference variable, TV, because TV is a derived class of the device class. So this is not possible. We are going to get the error message. If I save and come back, we also know that derived class reference cannot point to the base class instance, and we see in Y also. If I save here and come back, we get the error message. The error message is cannot implicitly convert type device to TV. An explicit conversion exists. To remove this error, we explicitly say TV. So we typecast it. If we say like this, if I come back, we will not be having any error message. You can see that we don't have any error message, only warning we have. And you can observe here, I have written TV device. I am telling to the system that don't worry, just convert this device to TV type. Why? Because I know that device is pointing to the TV. Implicitly now it is of TV type, so I can put that reference in a TV type reference variable which is on the left hand side. No problem for me. That's what I am telling to it. What system does now? It creates another reference variable here. It creates another reference variable with the name TV2. TV2. And it is of type TV. And we are telling TV2 equal to device. So it puts #1 inside. And as it is of TV type, there is no problem. It can point to this instance which is of type TV. We can see that we should not have any problem. And I can call TV2 dot switch on method. I can directly access the switch on method which is overridden in the TV2. What system does or the control does means it goes to this instance and executes this method, most inherited method, which is switch on. It displays TV switched on. I come back to Unity and just run and show you. We should not have any warnings. And if I run the code, you can see that first output we have device is of type TV, TV switched on, TV switched on. If you see the type also, you can see the for TV2 what is the type. If you want to see, you can see here. You can write TV2 is of type TV2 dot get type, and then you can display the TV switched on. It is of type TV, that we know that. If I save and come back and run and show you, you can see device is of type TV, TV switched on, TV2 is of type TV, TV switched on. So whatever we are expecting, we are getting properly. Now this is okay, no problem, perfectly it is working, good. Now here, let's create another reference type. Let's create AC. AC is equal to new AC, bracket, bracket, semicolon. And I say here, we have this device variable which can point to any of its derived class, we know that. So I can say here device is equal to AC, semicolon. Now this is no problem, right? Left hand side we have a base class variable, right hand side we have a derived class variable, there will be no problem. Now this time I copy these two lines and paste it down. Here what happens, we know that the device is pointing to the AC instance now. So implicitly it will get converted to the AC. If I display device is of type device.getType, we get here AC. And when we say device switch on, we are going to get here AC switched on. Let's save it, come back to Unity and run and check. If I run the code, you should see the last output as device is of type AC, AC switched on. Now you can see that AC is a device, TV is a device, and device can point to any of the device. It might point to AC or it might point to anything. This time, if I create a variable of type TV, TV3 is equal to device, 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 bracket, bracket, semicolon. I save it. I am writing this line over here, and of course right hand side is a device type, a base class type, so I have to explicitly say I want to convert it to the TV. I save this one. We will not be having any error message. If I come back, there will be no error message, right? Only warning we have. Here, if I say TV3 equal to TV device, we are going to get a runtime exception. Why we are going to get a runtime exception? We are going to get an exception. The reason is, here device is pointing to the AC instance. At present, implicitly device is of type AC, as it is pointing to the AC. I cannot put the AC reference in the TV reference, because AC is not inherited from the TV, right? Here, as right hand side is a AC, left hand side should be AC type. Here we are giving a TV type, so we are going to get an exception, that is the typecast, invalid typecast exception we are going to get. If I come back and run and show you, if I run the code, we are going to get an exception, you will find that soon. You can see that till here it has executed, all these lines got executed. When it came to that line number 49, it is telling that invalid cast exception. Cannot cast from source type to destination type. It is telling that I cannot convert here on the line number 49. On this line it is telling that I cannot convert AC type to the TV type. Now when you will be making a sophisticated applications, very large applications where you are having large number of devices, then you will not be having any idea to which device at present this device reference is pointing. Whether it is pointing to the TV, whether the device variable is pointing to the AC, or whether the device variable is pointing to the refrigerator, you will not be having any idea. Here only two we have. We know that just before this line device is pointing to the AC. I can very easily say that at present it is a AC, so I cannot put it on the TV. We are going to get the invalid cast. But when you will be developing larger applications, you will not be having any idea to which device the device variable is pointing. Understanding, friends? So if we do not want to get that exception, I do not want to get that exception, the invalid cast exception when I run, I want this code to be executed. Many ways are there for that. One way is, instead of using this typecasting method, we are going to use a keyword called as. Now read this as keyword. The as operator is used to perform conversions between compatible types. What as keyword does means, you have to write the expression something like this. Its form is, left hand side should be expression, that means a reference variable. Then you have to write the as keyword. Then after that you should write to which type you want to convert, or you want to check. Here I say as TV. Instead of writing like this bracket TV, here also same thing we are telling to the system that convert this device to type TV. Now by writing the as, we are telling to the system that take this device reference variable, try to convert it to the TV type. Check that whether it is a TV type. If it is a TV type, put that reference inside this variable, left hand side reference variable. Otherwise, what as does means, it puts the null inside it. It puts in this variable null. If I save and come back, we will not be having any error message. Stop this, clear this one. You can see that we don't have any error message, no warnings also. If I run the code, I will not get the invalid cast exception also. Can you see that? I didn't get any invalid cast exception. All the codes got executed. The reason is, here what it has done, as keyword tried to convert this AC reference to the TV reference. But we know that it knows that we cannot convert AC address to a TV address and put that in the TV reference variable on the left hand side. It puts the null inside it. So it is little bit safer. Understanding? Now I can say here, if I say TV3 dot switch on, I can access this method switch on from the TV3. But we know that as we have the null inside it, we are going to get the error message null reference exception. Till here there will be no problem. But when I try to say TV3 dot switch on, we are going to get the exception called TV3 switch on, because TV3 is having the value null. Null means we know that it is not pointing to any instance. Let's save and come back and run and check. We will not be having any error or warnings. But if I run the code, you will be getting an exception, that is null reference exception. Object reference not set to an instance of an object. It is telling that at present this TV3 is having the null, it is not pointing anywhere. How can you call? What you need to do in that situation means, we are going to use the if keyword and check whether the TV3 is not equal to null. If it is not equal to null, then only you execute this code. Otherwise, you should not execute this code. If I save and come back, of course we will not be having any errors. If I run the code, we will not be getting null reference exception also. Why? Because TV3 is null. So this condition, null is not equal to null, is going to become false, it will not execute this body only and it moves to the next line. If I save and come back and run the code, you can see that we didn't get any null reference exception. We already checked before executing that tv3 dot switch on, we checked that whether tv3 is not equal to null. Let's take an example of, now what I do, I just comment these lines. If I comment these lines and I save it, here we have only this much code, this part and this part. Here what we have, we created a TV and we are referring the TV by the device variable and we displayed the type of the device. It displays here TV type and it executes the TV switched on. I can comment this line also. I comment this line also. It is not necessary at present for the explanation purpose. Now we know that here device is pointing to TV. Device is pointing to the TV, and what I am doing here, I have created a reference variable called as a TV3 and I am telling take the device, convert it to the type TV. Now here what happens you should understand, guys. As we know that device is of type TV, it takes that TV address, converts it to the type, and we know that it is of type TV, so it converts. It puts that address into the TV3. So now TV3 is referring to a TV instance which we have created here. So we will not be having the null. We will be having some address. That some address is not equal to null. So the condition becomes true and it executes this line. We are going to get TV switched on in this line. Understanding? And we can put a breakpoint and check out. If I attach debugger, I have attached a debugger. I come back to Unity and run the code. You can see that we are over here. If you see TV3, TV3 is of type TV. Can you see that? And also you can see what is the device type. Device is of type TV. So as both are same type, it puts that reference and now it is inside this block. I hope you guys are understanding. I continue the execution. Stop this. I minimize. This is how you can use the as keyword when you don't know to which type the device is pointing, or base class reference is pointing to which derived class instance. If you do not know, you can use the as keyword and put to which type you want to convert, and you need to check that if it is not equal to null, execute that code, otherwise do not execute. So this is a safe side code execution. Now we understood how as keyword is useful. We find the usage of as keyword in many games, or when we will be developing games or any applications. You find this everywhere. It is very, very useful keyword. Try to understand this, guys. Now mainly as keyword you find when you want to convert the base class type and put the reference in the derived class reference variable if the base class reference is of type derived class. Most of the time you find something like this. There are other situations where you will be using the is keyword. Now when you will be using is keyword, I just show you and how you can use that one. Now we have a device and device is pointing to TV now. We know that it is pointing to the TV, so it is implicitly of type TV. I can directly check here if device is TV, bracket, and you can see what is. You have to write left hand side an expression, then the is keyword, then the type. The is operator is used to check whether the runtime type, that is this device reference variable type, is compatible with the given type. Is compatible with the given type is this TV. Whether both are compatible. If device is a TV type, then you need to execute device.switch on, bracket, semicolon. So directly I am telling that if device is a TV type, then you execute. So is returns boolean, true or false. It is not used for assigning equal to, like we cannot assign like this, but it is going to return true or false. If the left hand side reference is of type the right hand side, then it returns true. Otherwise it returns false. So as we know that device reference variable is pointing to the TV instance, it returns true and it switches on the TV. If I save and come back to Unity and run the code, you can see that TV switched on. We got the output. So that is is keyword and the as keyword, guys. We understand step by step a lot about how you can use the as keyword and the is keyword when we will be making more applications and games. You will see this as keyword also many times with arrays like this, as TV array or as game object array, like that you find. We understand step by step. Please watch this video again and again and understand how as keyword works, is keyword works, why we use as and is. Hope you guys have understood. So for this tutorial, this much is enough, guys. Keep learning, keep coding, keep sharing. See you in the next tutorial.